Hi everybody, thanks so much for coming this evening to the Building Centre. My name's Vanessa Norwood. I'm actually quite new here myself. I'm Creative Director of the Building Centre now. So this is my first talk here, and it's actually a great one to start with. This is a really brilliant project, so I'm very much looking forward to myself learning a lot more about this project. So the new Macallan Distillery is a project that actually opens this summer. It's on the site of the original estate that was formed in 1824. As you can see by this picture, it's set into the naturally sloping contours of the site. The design, which we'll hear a lot more about in a moment, makes direct references to the ancient Scottish earthworks. It was a very challenging project, I think, just because of the special nature of the landscape that it was set in. We are going to hear a lot more about it from our two speakers this evening, so it's an honour for me to welcome tonight, first of all, Toby Jeavons from Rogers Stirk Harbour Partners. You started in 2016, my notes tell me, is that right? No, you can't have done, because you've been working on this project for 6 years now, 2012. So you're the project architect, and you started in Rogers Stirk Harbour Partners doing Terminal 5, I understand. So it's amazing how you've kind of started off in the air, and now you've come down to the ground. Joining us this evening is Bob Lang, and he is Structural Engineer and Director at Arup. So you've completed projects around the globe, and you specialise in tall buildings and seismic engineering, and often working with multidisciplinary teams. And it's amazing when you look up your kind of reach and your remit on this project, because it seems like you've had to deal with very sort of particular set of circumstances to create a new distillery. So Macallan, I think we've already probably all heard of. It's probably one of the most famous whiskies in the world. And it wanted a new centre that could reveal the production processes and welcome visitors, while keeping this very sensitive site and the beautiful surrounding countryside. It was in an area of great landscape value that you've given your site. The materials that you've used have been local stone timber, and there's a living meadow roof, which I think we can see the picture of. So the estate was really important to Macallan, and that sort of must have set a very particular design brief, which I'm looking forward to hearing more about. So the actual project is cut into the landscape. The distillery taking its cues, as I said, from Scottish earthworks, and you can see the sort of undulating cells, I think you refer to them as. We'll be finding out more about that. So both the practice and Arup have worked closely with the Macallan in order to showcase the production of the whisky and the distribution lines. That's something that must have been a very particular project, and I'm sure unique to you both. So Arup, as I said, you provided structural, fire and building services. One thing that I noticed with some intrigue and maybe slight horror on your website, that in case of a fire, that there are no sprinklers on the site, that the response to a fire would be by evacuating up to 12,000 litres of spilt alcohol. There would be a few tears, I'm sure, if that ever had to happen, and I'm sure it won't. I also wanted to take the opportunity before I hand over to you both to say thank you to RIW, who are sponsors for the Welcome to the Underworld exhibition and to our event tonight. RIW are experts in waterproofing, and I'm sure without their expertise, you might have designed a swimming pool rather than this beautiful distillery. So yeah, thanks to them. Thanks also to Harriet Jennings at the Building Centre, without whose amazing research, none of this would have been possible. I have to say that we're really lucky actually to have this project, because it's not complete for 6 weeks. It means there is a press embargo, so this is a real coup actually to have this project tonight. So it means if you could refrain please from taking photos and posting anything. This is all at the moment top secret for about another 6 weeks. So I hope you can just sit back and relax and enjoy the talk. I'm going to hand you over now to Toby. We'll be able to ask a few questions of them both after the talk. So please, if anything interesting comes up, and I'm sure there'll be lots of questions, we will be able to put them to both Toby and Bob. So I shall stop speaking and say big thank you and welcome to the Building Centre. And I'm handing you over now to Toby. Thanks, Toby.
Okay, well, thank you very much, Vanessa, and to the Building Centre for the invitation, first of all, for us to be able to give a little talk today. As Vanessa has said, this is really a bit of a glimpse behind the red rope, as our client would say. It is still embargoed at this stage, and we were told to come, given the opportunity to come along and give it a little talk, and so I'd actually prepared just an introduction, really, by way of setting up the scene, and then obviously Bob can talk a little bit more about some of the engineering challenges that have been had. So actually your introduction was so good, actually, that I think you've probably set the scene from my broad introduction that I was planning to give. But I'll intro. Okay, so the Macallan Distillery. We were initially approached in 2012, summer of 2012, to participate in an expression of interest for an architectural competition, and which we were thrilled to do. And the reason being that the Macallan's existing production facilities were limited relative to the upturn in the single malt Scotch whisky industry. And as you've said, Vanessa, the Macallan is at the very top of the single malts. And big upturn in the American and the Asian markets had made them take the decision that they needed to expand their production and upgrade their visitor facilities. So they could have taken the view to just provide a utilitarian shed, essentially, to provide increased capacity, have new production facilities, and increase their capacity that way. But they've taken a sort of bold decision to do more than that. The leading brands director, as part of the client group, was very aware and influenced by a lot of the Spanish bodegas and the way in which they've put themselves on a tourist map and really elevated the status of that particular part of the drinks industry. So they entertained the design competition, and we'll come back to this, but this is called Easter Elke's House, which is what's actually on the logo of a bottle of Macallan, and is important because it's often referred to as the home of the brand, and it's very much a core part of the estate, which we'll see. So this is the Macallan estate up in Speyside. It's about an hour and a half between Aberdeen and Inverness, and this is the River Spey down at the bottom. It's about 130 metres above sea level, and this is the estate as we understood it at the time when we started the competition. The actual production facility is very small. The majority of what you can see here is built form, is actually warehousing, and you can also see that building there is Easter Elke's House, which is very much centre of their promotional material. The site that the competition gave us is this sort of plot up here. This was designated as part of the competition. And the views both from the site and back to it are fantastic. It's a beautiful part of the world. We've been spoilt, really, and been able to go here every couple of weeks for the last 6 years. There's a fantastic little Thomas Telford bridge just off shot of the main image at the top. And you can even see in the bottom right image some of the undulating natural landforms that are there, which would lead to some of the influences for the scheme as it developed. So the red line is obviously the estate boundary on this particular image. And the important point here is relative to the competition site, which was this plot, the straight line, the yellow highlighted line that runs down through the middle of the estate, was, at the time of the competition and prior, the only point of access into the whole site, both for production and for visitors. And our designated competition plot was just to the right of that. The yellow line itself, as Vanessa highlighted, is the boundary line of a particular landscape designation, which was the area of great landscape value. And that creates a corridor that runs parallel to the spay. And we, with our design partner Graham Stirk, who's the author of the scheme, pretty immediately took the view, well, even before we understood the way in which the process of making whiskey came together, that we would try to do something that would be sensitive to that landscape, use that as a principal driver, and mitigate its impact in the landscape. So at the beginning of a project, and we always demonstrate this in our competition submissions, we always do an analysis and a response diagram. Obviously, there's a particular topography to the site. We wanted to maximize the views from the particular, the broad site that we were given. It was very important that we made a connection back to Easter Elke's house, which is just down here. We wanted to do that physically. We wanted to make a physical connection back to the old house, but also symbolically, we wanted to always make that connection back to the home of the brand. That was very important. It was very important as well that the scheme, whatever it ended up being, didn't detract away from the house, which would always be the core element and which would always remain on the bottle. So the brief was to provide a production facility which had to be possible of being phased, and we were given three or actually up to 5 potential production capacities that the scheme had to achieve, along with a new visitor experience. We took the decision to locate the visitor centre with the production facility in one combined entity. That's quite unusual in itself. Often the visitor experience is separated away from the production facility, and that's normally for adjacency reasons against volatile products and volatile environments. But we chose to do that. We felt the visitor centre was really seen more as a reception to the production facility rather than something that was standalone. The authenticity of the product of Macallan dovetailed nicely with the authenticity that we would like to bring to a project of exposing the way that the component parts work. And so we always felt that it was a reception to the production facility. So the image on the right-hand side is the early response diagram, placing the visitor centre, which is this portion here, towards the southern end of the site, with an incised cut within the contours of the landscape that connect Easter Elke's house back to that visitor centre as a point of entry. We wanted to make almost a slightly kind of Mayan type of incision in the landscape that once you then break into the building, it would reveal itself and becomes the sort of mystery revealed, which became an expression that was often used throughout the project as well. You can see then moving further to the north of that initial circle are three further circles, and each of those represents a particular modular approach to a production, an amount of production capacity. And the image at the bottom as a concept section is really, again, highlighting the level change connection between Easter Elke's as the yellow image, navigating the level differences, bringing you in at a lower point within the visitor centre, and making that connection. So I show in a little slide later our initial understanding of how you make whiskey. We had to understand that process. And that began to inform the modular approach and the particular circular arrangement by which we wanted to arrange the principal production vessels. Typically in whiskey production, if anyone's been up to a distillery, you tend to have fermentation vessels in one particular area and the distillation vessels in another room. They tend to be typically separated. We chose to combine them together into one production unit. And that circular approach that we deliberately took to try and elevate the particular production copper stills then started to inform the rolling form of the roof, which in itself was interlinked with the surrounding landscape as well. So the merging of these two ideas of process understanding and and a landscape response. This image is just also to show the breadth of impact from an engineering perspective, way beyond the footprint of the building. In order to get this facility to work, we've had to have a whole spider's web of civils infrastructure that make their way back down to the river and up again. We have a series of effluent routes that are required for the removal of waste products, particularly if any of the liquid happens to be a light at the time. It's a very volatile product, as well as making connections back to an adjacent biomass plant for the generation of steam. There are too many sub-stories that I could talk about really for this in a short sort of 10, 15-minute talk. So it is very much an introduction. So this was just our initial, very quick understanding of how you make whiskey, and it was just kind of fun to do. But once we did do that, we were able to apply that very quickly to the production vessels that we were then aware that would be required, and that started to inform the actual plan in a bit more detail. So you can see here the visitor centre to the southern part, which is a combination of a taller, accentuated part of the roof with an exhibition space further to the south, and the 3 production cells moving further to the north, which are repeated. And the one to the very end is referred to as the mash house, and that's an introductory part of the process. All of this is exposed to the viewer, exposed to the visitor. So when they're able to walk around the scheme, which will happen in the early part of the summer, very much the production process is laid bare, and that's very important to us, that everybody can see very clearly how the building works, how the building's put together. To the rear of the building is also a production storage tank farm. Typically, whiskey distilleries have these incredibly utilitarian tank farms of malt containers and waste fluid containers as well, and they're very dominant on the landscape, incredibly so. So again, as part of the approach which would seek to mitigate its impact, we were able to double the, sort of halve the height, increase the number, and put those under the roof of the building as well. Technically, that became quite a complex part of the project. It's under a service road, which is sunken to the rear of the scheme, has to be ventilated. We've had many conversations with our local building control officer as to the designation of that space, and that effectively sets the layout. The roof, which I think Bob will talk about a little bit in a bit more detail, is a timber construction which was developed through a parametric modelling and was then developed via VHAG, the Austrian timber specialists. And we wanted to express through the meadow grass roof the grid, the 3-metre grid, which you can perhaps see on the image to the top. And that, going back to the original concept of the scheme, was so that the scheme didn't disappear. It was never the intention that this building would disappear into the landscape. It's very important that it's a product of man, that it's an engineered landscape, and that was very key. What that 3-metre grid also does, that's expressed through aluminium channels, which are gravel filled, is it provides fire breaks through the roof structure. It allows us to have irrigation pipe work, a whole lightning grid. So it's a very utilitarian working zone as well. So there's nothing on the scheme which is superfluous. I just included these just for context, really. I can bounce through these fairly quickly. But so short cross section. On the upper part of the hill are also some pretty unsavoury, very large maturation warehouses, which I don't think the client would mind me saying that. I think they agree. But what we've been able to do through the cut and fill of the excavation of the scheme is be able to recontour the hillside to the rear, and then with a particular tree planting scheme, be able to mitigate views of some of these warehouses, particularly from the anticipated new entrance sequence. So again, you can see these are actually from the original competition, just the elevation and the cross section. The slightly deeper element that you can see just in this zone was introduced by way of telling the story of how important wood is to the process of making whiskey. And it's an aspect that the Macallan make a very strong play of. And that's a very special maturation cellar, private cellar in the middle of the space, which is for VIPs. But every visitor will be able to see that during their journey. The roof, as illustrated here, is fundamentally as it is. The way in which the roof lights are demonstrated is a little out of date now. That was showing just a particular cluster of north light, but the way in which there's a halo of vents that have been located on each of the roofs to the production area, which both naturally ventilate the space, but also isolate and take away particular volatile gases from particular vessels below. And this comes back to the points that you raised, Vanessa, in your introduction about also making linkages back to long cairns, barrows, and circular brock structures, which are evident obviously in ancient Scottish earthworks, which we were able to reference and that's a rendered scheme in, obviously, as an overview. Slightly more technical drawing, again, just to show the complexity of the scheme. We've been working on it for 6 years, and I think it's probably fair to say that almost every single part of the project has had its challenges. That said, it's been an incredibly enjoyable project to be involved with, and I think it's just coming to fruition, and hopefully it will be well received. And then to put some construction images in, where you can see the layering of the roof and the particular scarring that was temporarily required to the landscape to open this building up. And I'm sure Bob will talk a bit more about the particular nature of the retaining wall and the aspects of the structure related to the roof. But we just like this particular image. You can see the warehouses that I referred to earlier at the top of the hill, which is what we were trying to mitigate through some landscaping. And there you go, that's just a nice counterpoint with the hills in the distance. These are these particular access grids that I was referring to running across the roof, backfilled with a Scottish meadow grass, particular Scottish meadow grass seed mix. And you can see the service road also to the bottom of the image. This is just slightly prior to the tail of the roof being installed. And then these are, just to sort of sum up, really, these are just some glimpses, really, of a not quite, but very soon to be opened and finished scheme. So this is the view up the entrance cut, obviously, seeing the rolling hills drift out of view, and you can see to the left-hand side where this is going to have a particular oak arboretum to the left-hand side, which is picking up on the component parts of the importance of oak in the production of the whiskey. That's the view at the top. And then that's just a great shot. That's the Macallan have got a great interest in photography, and they've got a number of overlaps with Magnum, the photographic agency. And during the process of construction, a number of Magnum photographers have been employed and have taken a particular angle, so to speak, as to which part of the scheme they would like to reflect. Some are more landscape-based, and some are more people-based or construction-focused. So, and then this is a little out of date. This is from September last year. So actually, if we were to go here now, you would see quite a bit of difference. But nevertheless, you do get to get a sense of the scale of the building. It's about 60 meters wide and it's about 220 meters long, just to put it in. Beneath the tree line here is a separated visitor access road. So unlike the scheme before the project, where all traffic came in at a particular point, the scheme is now separated. We have visitors, front of house traffic is segregated away through the tree line here, comes down to a new landscaped car park, which gives you a glimpse past Easter Elkie's house before you then make your way up that entrance cut and then in underneath the the earthworks into the scheme, which then reveals itself. Unfortunately, I can't show any of the internal images, so I'm afraid I am limited on what we can discuss. But as I say, it is a glimpse, and it is a little introduction, a little teaser, really, I suppose. So that's about it, really. That's just a little taster. I hope that's okay. There's not a lot more I can say at the moment, but I'm sure things will come out from the Q&A. So
we will question you closely.
Yeah, I'm sure you will.
So,
yeah.
Yeah, thank you, Toby.
Okay.
Thank you. Yes. Thanks, Bob.
Which do I press? This one? I wish I could say that these were epiphany sketches. They're not. This sketch particularly defined the very early discussions that we had as a team going back into 2012. There was an interest in creating a dome above a circular array of stills, and the shape isn't willful. The stills are very hot, 100 degrees or thereabouts. The air above that is also very hot, and it rises. So in order to minimize the amount of motive force that's needed to push the air through, if we could let the air rise and actually let the air out of the roof, you could minimize the amount of fan power required to clear the air. That meant that we needed to look for a form, a domed form. It just happened that it fits into the landscape very well also. So we looked at a catenary, an inverted catenary, which have certain properties, and and if we could match the slope between the catenary and its opposite, the arch, then we might find an interesting form. It was the start of a discussion. That is all. This one. So. These notes and things are a summary of a position in time. They're not the epiphany moment. So we looked at taking the catenary or something similar to that and making a revolute and arranging those domes above a circular array of stills. And carry on the tension theme. If we could lay a veil over that, drape a fabric over that, we will get a very clean point of inflection between the skin and the dome. And it's kind of very simply represented there. The second major point was that whilst the building appears to be buried, it's got 6 inches or thereabout of earth over the top of it, so it's not very far underground. But it meant that we could do it cut and cover, so we could actually carve the hillside clean and build on the virgin ground, which was quite good. And by doing a cut and fill exercise, we might balance the amount of excavation that was required. So that being the case, these were some of the very early models that we used. And the geometry was created in an analytical space. We created domes of a certain size and arrangement, centered over the stills. And over that, we laid a fabric, an analytical fabric, if you like. And by altering the properties of that fabric and respecting the boundary conditions, we're able to make sure that we got semi-decent folds for the water to bring the water to the edge of the building and drain it. It also gave us a combined surface with a constant point of inflection, where we could possibly put some support. Because what we didn't want to do was to take the retaining walls all around the building. We didn't want to take that force into the walls. We wanted the roof to be completely divorced from that, so that the timber literally just worked to support the roof and the earth. And this is what that manifested itself in being. Life being what life is, we didn't actually find the point of inflection between the fabric and the dome. It was just off. And to those of you that understand these things, that means you've got pretty high shears to deal with. Not perfect by any means, but it was a starting point for a discussion. And what you see here is the ring structure that effectively picks up the end of the dome, and also, because of its shape, it can take all the lateral forces. So the imbalanced snow load, the wind load, and anything that gives imbalance to the top surface of the structure is taken in that steel work. And what that means, we can liberate the roof from any forces from the walls. For a buried structure, that's quite a difficult thing to do often. You look for the roof to be a membrane. Our friends at SH Structures helped us with the steelwork, and VHAG the timber roof. I'll talk in more detail about how these particular foams were developed later. Now, once we developed the surface by the means I described, we were then able to look at how that surface performed. And what you see, the purple is really where the high compression forces are, and there's steelwork in that location. But basically, you've got a series of ribbons from which this whole thing is supported. And those of you that know timber has some capacity. It's not fantastic. So we knew that we would have some quite high tension forces to deal with, which we did. At the same time, we knew that that's one condition. The second condition was we knew that timber is particularly sensitive to temperature and relative humidity. So we did some computational fluid dynamics, which modeled the vessels at their temperature. We made assessments of the relative humidity of the air, and were able to predict. It's a prediction. The temperature and relative humidity immediately adjacent to the timber at the roof. And it was reaching circa 40 degrees, which is hot. And we tried to keep the relative humidity above 20%. Because the timber, puts in very simple terms, we didn't want the timber to dry out too quickly or distort or become brittle. There was much wailing and gnashing of teeth went into that discussion, and we agreed with VHAG some limits, which we were able to justify analytically. And measurements today in a semi-functioning facility are reasonable. Sorry. What that then allowed us to do was to put some form to this roof. And I'll speak to the geometry now, if I may, very briefly. Once we got this surface, domes and veiled fabric, if you like, in place, we drew a 3-meter grid on the ground and projected it vertically. And that allowed us to plan certain things with a large degree of rigor. The process is an extremely complex thing and needed coordinating. There were vertical things to coordinate. So we projected a 3-meter grid onto the formed surface. And then that gave us the position of all the elements, which you can see there. We had predominantly timber, but accepting that there was going to be tension, our design was such that we would create a hollow box of a fixed dimension and put steel down the middle, or whatever was needed down the middle, we could tune that form. Because your gut tells you that something about 500 mils too shallow, meter 50 is too deep. Something around 750 a meter would probably look right in scale terms. Now, don't ask me why you make those decisions. They're the kind of instinct. You know that. And we began to test that. So, silly sums, and they are silly sums, but they tell you where you are in very reasonable terms. If you just said that it was a beam that spanned between the points of contraflexure of a dome, it would need a certain size. It failed miserably, so we said we put some steel in and made a provision of 12, 15 kilograms a square metre of steel work to make that work. But the 750 by circa 100 was the kind of scale of element that we were looking for. And these are just really early attempts at trying to decide what planet we're on. In the end, we took these kind of sizes. So we ended up with a 750 deep, 160 wide, plus LVL cheeks. So we added it with a glue lamp, because that's what VHAG could make quickly. So it's not bad guess. When we ran out of capacity, we pushed the top of the beam up into the cassette zone, which is the timber panels I'll show you later. And then where we had really big forces, we were going to put steelwork. They twisted our arm and said, can we do this in timber? Why not? So we got one or two really big pieces in there that really didn't relate in any way to the first analysis, but worked all the same. And what you see here is the physical manifestation of that. There's a whole story on angles and cuts and bespoke geometry. Essentially, because you project the 3-meter grid onto a surface, everything changes length. Well, because it was circular, you got repetition. And because it was triangular, based on a square, you could create something that wasn't warped in itself. So there was a certain logic to that. The detail always is, the devil's always in the detail. Here you see it, that's the physical manifestation of what I've just described. So we got a very rectilinear system, and timber likes being stacked on top of itself. It'll bend a bit, it'll stretch a bit, and compress a bit. But generally, unless you really do what timber wants to do, you'll be challenged. In much the same way that concrete was challenged when it was faced with tension. Why not? So we took the decision to reinforce it. To this kind of effect. If you stood underneath that and lay on your back and looked up, it would be a perfect square. There's also a very natural hierarchy here, because there are big arch beams that go mutually perpendicular to each other that sit on these steel frames, and then they are infilled with secondary elements. Down the center of the big arches are pieces of steel. Where timber alone works, we just use timber. And for those of you who are interested in structures, we do not rely on the panels to be a membrane. They want to. They cry out to be a membrane. But we didn't let that happen, because the local bending was weak and the shears were quite high. So we took everything in axial and bending in those rectilinear beams, and the panels really just clipped on top. Moving quickly on, this was the doodle of that era, and it wasn't 3 meters deep, it was nearer 15 meters deep. The water table was relatively low, the ground was good, so we were able to do an open cut, a battered open cut, and create a 9 meter, occasionally 15 meter high freestanding retaining wall. Freestanding, very important. It didn't rely on the roof to stabilize it. The physical manifestation of that is what you see here, which is about a 300 meter by probably 80 meter scar in the landscape, which at the time was done in remarkably good condition. We had a great summer and a great winter to do this. And one of the big problems was, and the big environmental statement here is that no runoff reached the spey. So we developed a whole series of holding ponds, cut-off trenches, attenuation that stopped the silt effectively reaching the spey. So whilst this building appears to be underground, it was actually built in open cut, and then it was backfilled completely. And our friends from RIW we owe a debt of gratitude too, because there were some pretty complex waterproofing details there. And we control groundwater rather than take the pressure on the wall. Said wall, it's a counterfort wall. All this was backfilled. That's about 9 meters freestanding. This goes up. The big wall you see here is about 15 meters or so, and the roof literally just sits atop of that. So there are sliding joints that allow that to happen. So all the major stability is under the ground. We got told off by the contractor because he thought the counterforts were too big. we said, well, here's the perfect diagram for each counterfort. They were all different. So in the end, by standardizing the size and standardizing the reinforcement, that allowed them to push through very, very quickly. There's no movement joints in the wall either. It's 250 meters long. So we literally reduced the section to concentrate to relieve the longitudinal stresses and did a pour sequence. So those that are interested in those things. Yeah, pretty much more of the same. Friends Carey doing the concrete and SH Structures doing a remarkable job on the steelwork. Very, very close tolerance. We said to VHAG, what's your tolerances? We don't have any. It fits. Where's Mark? It was about right, wasn't it? Something like allegedly. But they were very good with turfers and things. Not much more to say there. This shot kind of sums the job up, really. What you see at the top there by the river is the holding pond. Because what happens is, in a catastrophic event, as you alluded to, rather than sprinkler the whole thing, which would just kill the space, quite frankly, we were able to prove that when one vessel blows, that the liquid can be evacuated in a fixed time. So the ground slopes to a drain. That drain then comes out of the building to the front grid line 2, which you see this side being that way. And once the fire alarm goes off, by some magic of the fire engineer, we're able to turn a valve that, instead of it going to the effluent plant, takes it down to a holding pond here, and is then held there and taken to contaminated waste. So there's a really complex, it's a great story on the civil engineering. Come back and talk about one day. This is, again, particularly interesting because it demonstrates all phases of the roof, which Toby has talked about already. Finally, I've just put this in because this is the Revit model for the whole thing, right down to the joints. But you can see the scope of the job. There's huge retaining walls below ground with hundreds and hundreds of meters of retained earth. And the roof structure atop with the steel braced frames underneath, and those braced frames fixed down to the concrete structure and thereby to the ground. And in however long that took, that's about 6 years' work. There's 3 more stories to tell. Maybe you'll have us back. That's it. Thank you.
What strikes me about this amazing project is the kind of amount of original thinking that you had to do. You talked, also it's beautiful seeing that drawing of the process of distilling the whiskey, and that does seem to have really had an impact on the final form. But you talked about Mayan architecture, you talked about the kind of earthworks and the bodegas, which I think the practice has already built bodegas. Were there other references you could use with this kind of, the project seems so original. Was there anything else that you could kind of reference and look at to help you?
I think there's been, that's a good question. I think there's been, no project, of course, is truly original in some senses.
Yeah.
I mean, there's no, at one level, there's that expression of, there's no such thing as a new idea. And I think everything is building on previous experience, certainly from ideas that may or may not have come to full fruition previously, that maybe a new project gives the opportunity to develop and try things again, perhaps. Yeah. And I think, hopefully, there's a certain truth to what we were saying earlier. I think it was, the concept did merge and come out of an understanding of the way in which whiskey is produced, the way in which that process diagram works, reorganising it critically, I think, reorganising it because the brief required it to be a phasable scheme. We had to have X million litres of whiskey so we knew from the very good briefing that we had that in order to create X million litres, that requires so many of this type of vessel, so many of that type of vessel. And we were able to kind of do various options as to how that assembly might work. And we came to a particular arrangement, a circular arrangement, and also by elevating it, changing its level in a particular way, you can, by elevating that, drawing sections, you can pretty quickly begin to sort of draw a curving envelope over the top of that. And I think that when that kind of thought process is then interlinked with the response to the landscape, and an instinctive response to try and do something which is sensitive, those two thought processes started to merge, started to come together. But you're obviously aware of the whole kind of canon of work that's been done before, and so you can't. You know, it's no such thing as completely new, but you take that influence.
I think also it's fair to say that there's no part of this that is superfluous. There's purpose behind virtually every decision. The hills, whilst they are, you could poetically describe them as being a reference to the landscape, etc., etc.
Yeah.
There is still a real, on the underside of that, there's physics. The hot air rises. We don't want to put too much energy to force it through. We naturally ventilate this because it's very low grade heat actually, so you can't do much with it, which I suspect will be a question. So once you lay the stills out, you get the dome geometry. You look at the way that the air wants to move. You minimise the amount of forced ventilation that you need. And whilst this does create an extremely poetic statement in an area that demands a poetic statement, then, there's more to it than that, if you like. It is actually quite a highly functional space. There's nothing that you would say particularly willful.
No, I mean it is a kind of agro-industrial building still at its core. It's a production space, and we were also keen to. I mean, it's the layering of ideas, I suppose, that start to come together. But we and the client were also keen that the scheme wasn't one. You didn't experience it as one large volume. So I think having the undulating nature of the roof as well. Also, when you internally you experience it as a series of cells. You experience it as a series of very large rooms that you move from one to the other. And I think that was important as well, just for the drama of the internal space, the lighting that you're able to create from that.
Yes.
And just to break down the scale of it a little bit. Yeah.
And that narrative is very clear in that early sort of process drawing, isn't it? So it's a beautiful embodiment. So do you think the client had a kind of idea in there?
No, I don't think so. Not as far as the actual ultimate form. I think they had a great ambition. That was the key thing. It was a game-changing thing from the Scotch industry. I mean, whether or not we begin to see. It was interesting that there was actually something on the BBC today about a particular investment from Diageo, I think, in Scotch. So whether or not there's going to be a new wave of whisky experiences which are sort of a bit more elevated in their ambition.
Yeah. Yes.
But certainly the Macallan have taken an idea and run with it.
Yeah. Well, it seems a great client.
Great client. Yeah. Couldn't complain really. I mean, they've been a wonderful group of people, nice group of people, lovely geographic part of the world. So I mean, it has been a real privilege.
And a great subject matter.
A great subject matter. Yeah.
I'm going to ask if anyone here has a question. Sorry, I happened to look to you first, so if you'd like to... I don't know if we have a roving microphone. So if you can maybe give away slightly who you are before you ask your question.
My name is Michael Herman from Kingston University. I'm curious about whether my first thought was whether it was entered into the BREEAM scheme and whether there was any sort of environmental standards by which it was being assessed. And, well, if not, anyway, I'm just wondering if either from yourselves or from the client there was any sort of sense of analysis of what the embodied energy was that went into the building versus the energy in use over the lifetime of the building, and any sense of the the design life of the building?
Yep, I'll take that. I suspect your question is steeped in areas that don't involve whiskey design, to be perfectly frank. Or manufacture. So let's just separate those two things apart. The whiskey process is immensely energy consuming. It requires a huge amount of heat. From their point of view, they extract water from the River Spey. They use it to heat and cool, and it goes back in at 3 degrees C. So other than the fluid that comes out of the stills, the water is recycled. In terms of heating the process, that comes from a biomass plant close by. So the energy that goes into making the whiskey is as eco-friendly, green as it possibly can be, given the demand that they have. So if you separate that to one side and bring into play the more, I suspect, the bit that you're more familiar with, we did recycle some of the process heat from the visitor centre, and we had an immensely insulated roof, which is what you don't want, quite frankly. You don't want an insulated roof. You want to insulate in a classic sense, you want to protect the earth on top, so it's kind of there's a huge amount of heat under there, but you don't want to kill the grass on top. So there's a kind of reverse problem, if you like. So most of the heat loss, or the heat generated, comes out as air, convection, and then that convection with a little bit of assistance comes out through the top. In terms of the Scottish equivalent of Part L, we were under immense pressure to satisfy the parts of the building that were classic building, if you like, and we met their highest standard, if you like, by reusing as much energy from the process as we possibly could. So did we reach LEED this or Platinum that? Probably not, no. But did we do our best to make best use of what was available to us? Yes, we did.
Thank you. I think that answers that. Anyone else got any more questions? I'm sure there are. No? I mean, yes, thank you. So how many months were spent on the design of the kind of use of the space, and who was consulted? So were the workers consulted about how they would use the space? I almost want to guess, but I won't actually. So I don't know if Toby, that's a you question.
Well, I'm not entirely sure quite what your definition of space is in the nature of the concept of the question, but I mean.
So the internal arrangement, the roof structure, the volume.
Yeah.
Do you mean the kind of experience of being in that as a sort of?
Yeah. How the layout. Mm-hmm. You said it's quite unique, but not, you've got.
Yeah. Well, I think the way in which we tend to design is that we're very aware of the internal environments that are being generated all the time, and it's that you don't actually kind of we're not putting the structure in one box and the space in another. It's the design is being created in one go holistically, and you're very aware of the spaces that are being generated by some of the structural decisions that are being made, and we're analysing those all the time through, as best as one's possible, through 3D modelling and through understanding the space to put ourselves in there as best as we possibly can. I mean, I think personally one of the things that's particularly nice about this project, from my experience of our practice, is that actually from a place perspective, it is very unusual and rich. There are a number of very particular spaces within this particular project. We don't all get the benefit of working on a project like this at all. So
designing or have
it's long, isn't it?
I think 6 years, isn't it?
Well, the design of the building, I suppose, if you want to kind of break it down into, I mean, we obviously, within the first, we submitted for planning in about a year or so after the competition. So it was, the major moves are actually made within that period, but it's constantly being developed.
Yeah,
it's not a line in the sand. It's
exactly.
constant iteration and involvement and discussion from all parties.
I mean, this project seems very sort of complex in terms of the sort of, you had to kind of think about the incredible heat that you talked about, Bob. I mean, there seems to be an unusual set of circumstances in that process that must have meant that the overlaying, I mean, it just seems a very exacting, very complicated project to have worked on.
It is, but it just means you take things back to first principles.
Yeah.
Allows you to question.
Right.
So there's very little there that, there's some precedent, of course, at a certain level there's precedent.
Yeah.
But finding a way of using the engineering in its broadest church to solve many problems and interlinking them,
Yes.
creating architecture out of problem solving, and creating problem solving, creating, and so on.
Yes.
So, because there's so much first principles work, then it's labour intensive. It takes a long time, but you don't. And I would say, if you want a straight answer, probably 18 months to get to a decent set of information, and then another 18 months or 3 years refining that with suppliers and solving problems on site. So, probably something like that.
So an amazing project to work on in terms of that sort of getting back to basics and testing principles. And I mean, it must have been a brilliant learning curve, and that's not a reference to the form of the building, but just kind of being able to test out the sort of solutions that you needed for such a complicated building.
And we were blessed with some really good contractors. I'm not just saying that for the sake of saying it.
No, I mean, you can see the complexity of the build looking at it. Not just the waterproofing, but you were describing the timber grid shell of the ceiling of the roof.
I was going to say, actually, I realised off and made a couple of notes. There are a few things I slightly forgot to add in. And the one of the things that's of interest, I mean, the brief for tonight, of course, was actually kind of like a 10-15 minute introduction. So it's hard to focus on the particular points of interest. But the reason that I mentioned about us choosing to place the visitor centre and the production facility next to each other, because we viewed the visitor centre very much as a reception.
Yeah.
But the reality of that decision meant, and because we wanted to reveal the process, meant that the dividing line, the wall between the visitor centre and the production facility, which has to be a 2-hour fire compartment, but we wanted that to be a totally glazed, fully sort of picture window onto the production. So that takes the valley line between the principal dome of the visitor centre, and it's 10 metres tall. It's the full width of the building. It has to achieve a 2-hour fire rating, but we didn't want to do that through a number of options that we looked at. So by way of example of a piece of sort of innovation that was able to be developed, was it works through a whole sprinkler drencher system, which is the exception to your comment about sprinklers.
Right. So no alcohol was spilt, none will be spilt.
No. Well, the reason for the drainage strategy is also is to prevent a pool fire that can occur. So if you well, copper has an innate vulnerability to wear out, frankly, over a number of years. And so it's true within the whisky industry that in order to avoid a catastrophic event where you could have a failure plus a source of ignition, that you need to get rid of that within a certain amount of time.
Gosh, so you hope, as well as doing kind of distillery lessons for visitors, that there'll be an architectural version available to would-be engineers and architects seeing that space, because it's so, this kind of, the particular solutions you've had to come up with are amazing, I think. Has anyone else? Yes, sorry, I can see a hand over there. Hi.
Hi. Congratulations for working on such an interesting project. A small question. Given presumably there are heavy-duty vehicles transporting the products away from site, and the undulating roof emerging from the ground, was security deemed an issue, or given it's a
From
private
a
estate?
kind of theft of product.
No.
perspective,
So,
or-
for example, a malicious driver or driving on the roof and causing damage, because that could be.
Yeah.
It's just
Well,
I'm seeing the image. I'm not sure whether.
Yeah,
there
no,
are
I mean,
other
there's
barriers.
actually, I mean, this is actually this is a pretty early rendered version. The reality is actually that in order to prevent a pedestrian just walking onto the roof as well, because we didn't want to have handrails around the outside, so the way in which the roof engages with the landscape on this long western edge and the northern edge, you actually read the timber structure. So that timber structure exposes itself and is expressed, and that sits and that creates a natural sort of 1300 high barrier. That starts to prevent the pedestrian, but also then that is extended as a tail across this service road, which again creates a barrier. But then there's earth which is bermed up behind that again. So it's impossible for a vehicle to actually get.
It's a ha-ha, effectively.
Yeah, it's like a heart.
Right.
Yeah.
It does look very tempting, doesn't it, to sort of have a little joyride across the... yes, sorry, over there.
Yeah, during the description of the description of the roof structure, you said that you couldn't quite, when you were draping the grid shell over the domes, you couldn't quite get a perfect match between the dome and the catenary.
Yeah.
Did that come as a surprise to you, or were you sort of expecting that you'd probably have to slightly fudge it?
No, we expected. And we expected it because we were in a very puritanical environment when we did the fabric analysis. The domes, because of the heat rise, the fabric to try and get a control point of inflection or a transition between the dome and the landscape. So what we did was we in analytical terms, we created tension in this fabric that was draped over, and that basically it rose and fell and curved and found its natural place of repose given the constraints. So we knew that we had an equator of inflection around each dome. So that in the virtual world, perfect. But once you make the decision to project a rectilinear grid onto this curving surface, it becomes faceted. And there is a change in height as you move around this thing. We made the decision to take the steel tube through the center of the steelwork so that we could transmit bending, axial, and torsion. So there were no built-in eccentricities into the steelwork as such. So that's number 2 on the step. When you reach number 3, what that tells you is that the absolute point of inflection, where perhaps the moment is 0, is not where the tube is. It's slightly off, and it's off for very good reason. What you then got to do is say to yourself, well, how am I going to take the resulting shear out? And what we did there was to put some embed plates into the timber, get that past the point of critical shear, and then that was then fixed to the steel tube. So how can I answer your very direct question? We were not blind to the fact that the point of inflection would move. It was a product of building the roof.
I think we've got time for one last question, actually. Maybe that.
Briefly, but what would be your next grid shell?
What would it be?
Yeah, having done this, what would you like to move on to?
Well, this system is quite interesting because if you have an irregular roof that doesn't follow such clear rules, then you can have the wonkiest geometry you want, and you can change the depth and the width and the height of these downstands to compensate for the lack of geometry. And the engineers in the room will go, you can pour material at it, and that's all that happens is you can't defeat geometry. Geometry is your friend or your foe. And here we try to make it our friend. If it's too bad, it will become your foe and you have to compensate for it in bending. The next one I would do, it's very, well, we're looking at one in Vietnam now that uses we deepen the ribs in concrete, for example. So we'll keep with that for a while and see what happens. The Paul Clay Museum, which some of you may know, in Bern, we looked at doing a very pure shell there. And Isla and others were plaguing us the whole time, telling us we could. Once you get too much bending in and the geometry defeats you, you've got a problem. So you just got to compensate for it.
I think we're going to draw the evening to a close there on that note of bearing in mind to make geometry your friend. So I want everyone to go home with that thought. I want to say a massive thank you to both of you, to Bob and to Toby, to telling us more about this incredibly unique, interesting, most complicated, original building. And to say, I'm sorry we can't share any Macallan with you this evening, but we have got some wine, so we'd love you to share a drink with us outside. But yeah, thank you both so much.